Good afternoon, everyone. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. Today, we are going to be looking at another section of differentiation. So, we are going to be looking at differentiation of inverse trigonometric and inverse hyperbolic functions. So, now we are going to be seeing how to differentiate sine inverse of x, cos inverse of x, and tan inverse of x. So let's get started. Now, if y is equal to sine inverse of x, and we're asked to solve for the y all over the x. Yes, solve for the y all over the x if y is equal to the sine inverse of x. If y is equal to sine inverse of x, it therefore means that our x will be equal to sine y. Yes, if y is equal to sine inverse of x, our x will be equal to sine y. Now, the x all over the y, when you differentiate sine y, it gives cos y. Now, remember, under implicit function, we said whenever you differentiate a function of y with respect to x, you have to follow it with the y all over the x. But in this case, we actually differentiating with respect to y. So you don't need to follow it with the y all over the x. Now, the x all over the y is equal to cos y. So it means that the y all over the x, will be equal to 1 all over cos y. Yes. Now, the reciprocal. The x all over the y is cos y. So it means the y all over the x now will give us 1 all over cos y. Now recall from trigonometric identity. Yes, from trigonometric identity, that sine square y plus cos square y is equal to 1. Yes, sine square y plus cos square y is equal to 1. So it therefore means that here, our cos square y, this is equal to 1 minus. Here we have plus sine squared y. So taking it to the other side, it becomes minus. So here we have 1 minus sine squared y. Now, it therefore means that here, our cos square y is equal to 1 minus sine squared y. Now, cos y. If cos squared y is equal to 1 minus sine squared y, it means cos y will be the square root of 1 minus sine squared y. So that will give us cos y to be equal to the square root of 1 minus. Now remember we said let x be equal to sine y. So if x is equal to sine y, it means sine square y will be equal to x squared. Yes, sine square y will be equal to x squared. So it therefore means that here we have 1 minus x squared. Yes. So cos y is equal to 1 minus the square root of 1 minus x squared. Now coming back to the y all over the x. The y all over the x will be equal to, here look at it. The y all over the x is equal to 1 over y. So it means here we have 1 all over the square root of 1 minus x squared. So that is the value of the y all over the x. So it therefore means that if y is equal to the sine inverse of x, the y all over the x will be equal to 1 all over the square root of 1 minus x squared. So that's the value of the y all over the x if y is equal to the sine inverse of x. Now, let's look at cos inverse of x. If y is equal to the cos inverse of x, and here we are asked to solve for the y all over the x. Now, in this case, we have cos inverse of x. So now the value of our x now will be equal to cos y. Yes. So if y is equal to the cos inverse of x, x will be equal to cos y. So now let's look at the x all over the y. Now we are differentiating with respect to y. When you differentiate cos y, it gives minus sine y. Yes, that's the derivative of cos y, minus sine y. So now let's look at the y all over the x. The y all over the x will be 1 all over sine y. Yes, minus 1 all over sine y. So now, recall sine square y plus cos square y is equal to 1. Yes, from trigonometric identity, sine square y plus cos square y is equal to 1. So it therefore means that here, our cos square y, sine square y will be equal to 1 minus cos square y. Yes, sine square y will be equal to 1 minus cos square y. Now, removing the square, it means our sine y will be equal to the square root of 1 minus cos square y. And remember, we said let x be equal to cos y. So if x is equal to cos y, it means the value of our sine y will be equal to the square root of 1 minus. Now, cos square y now will be x squared. So here we have x squared. So it therefore means that here, the y all over the x, which is the same as saying minus 1 all over sine y, will be equal to minus 1 all over the square root. Now, sine y is the square root of 1 minus x squared. So here we have 1 minus x squared. So that is the value of our dy dx. So therefore, if y is equal to cos inverse of x, the y all over the x will be equal to minus 1 all over the square root of 1 minus x squared. So that's the value of the y all over the x. Now, let me tag this one, the first one, as number 1. Now, the cos as number 2. And now, let's look at number 3 now. Let's look at number 3. Yes, y is equal to tan inverse of x. Find the y all over the x, or solve for the y all over the x. Now, in this case, our x, or the value of x, will be equal to tan y. That's the value of x. So now, let's look at the x all over the y. Now, when you differentiate tan y, it gives sec square y. Yes, when you differentiate tan y, it gives sec square y. Now, let's look at the y all over the x. The y all over the x now will be equal to the reciprocal of this now. So that will be 1 all over sec square y. Now, recall, sine square y plus cos square y is equal to 1. Yes, sine square y plus cos square y is equal to 1. And we all know from trigonometric identity that sec y is the same as 1 all over cos y. Yes, sec y is the same as 1 all over cos y. So here I want to divide through by cos square y. Yes, by cos square y. So it means here we have sine square y all over cos square y plus cos square y all over cos square y is equal to 1 all over cos square y. So now here we have sine y all over cos y all squared plus 1 is equal to sec squared y. But sine y all over cos y is equal to tan y. Yes, tan y is the same thing as sine y all over cos y. So it therefore means that the value here will be tan square y plus Yes, because this sine y all over cos y is tan y. So it means sine y all over cos y is tan y, then the square of it. So it becomes tan square y plus 1. So here we have tan square y plus 1 is equal to sec square y. Yes. So it therefore means that here, the value of our sec square y is the same thing as tan square y plus 1. Yes. Sec square y is tan square y plus 1. And now we said that the y all over the x, the y all over the x is equal to 1 all over sec square y. So that will give us 1 all over tan square y plus 1. But recall here that tan y is equal to x. X is equal to tan y. So it means this is the same thing as saying, yes, recall that x is equal to tan y. So tan y is equal to x. So tan square y will be equal to x squared. So therefore, the y all over the x will be equal to 1 all over tan square y, which is x squared. Then here we have plus 1. Okay, so that ends the derivative of inverse trigonometric function. Now I want us to look at that of hyperbolic function. Now for hyperbolic function, let's look at y to be equal to, now let me call this number 4. Yes, we have actually finished with the inverse trigonometric functions. Now I want us to look at inverse hyperbolic functions, because what we're looking at here is differentiation of inverse trigonometric and inverse hyperbolic functions. Now number 4. Yes, if y is equal to sine h inverse of x, and here we have to solve for the y all over dx. Now let's look at this now. Y is equal to sine h inverse of x, solve for the y all over dx. Now in this case, if y is equal to this, it means our x now will be equal to sine hy. Yes, x will be equal to sine hy. Now let's see the value of the y dx, the x all over the y rather. So the x all over the I, when you differentiate sine hy, it gives you cos hy. Yes, when you differentiate sine hy, it gives cos hy. Now let's look at the y all over the x. Now the y dx now will be 1 all over cos hy. Yes, 1 all over cos hy. Now recall from hyperbolic function. Yes, hyperbolic function. Now cos h square y minus sine h square y is equal to 1. Yes, it's equal to 1. Unlike trigonometric functions where we have sine square y plus cos square y is equal to 1. We all know that trigonometry actually came from cycle, y hyperbolic from hyperbola. Yes, so in this case, it means that cos h square y minus sine h square y is equal to 1. So here, our cos h square y will be equal to 1 plus sine h square y. Yes, cos h square y is equal to 1 plus sine h square y. So it means our cos hy, removing the square, will give us the square roots of 1 plus sine h square y. Yes, please, this is y. Take note. Yes, that's y. So now the y all over the x. The y all over the x is equal to 1 all over cos hy. Bets. Let's look at the value of our sine hy. Yes, sine hy. Now remember our sine hy is equal to x. So if sine hy is equal to x, it therefore means that sine x is equal to sine hy. So the value of our x squared now will be sine hy all squared. And that will give us sine h squared y. Yes, that will give us sine h squared y. So it therefore means that here, the y all over the x will be equal to, we have 1 all over the square root. So here we have the square root. Yes, because here we say cos hy is the same thing as the square root of 1 plus sine h squared y. So it means that will give us 1 all over 1 plus x squared. Yes, so this is the derivative of sine h inverse x. So it therefore means that if y is equal to sine h inverse of x, the y all over the x will be equal to 1 all over the square root of 1 plus x squared, or you can also call it x squared plus 1. So that's all about sine h inverse of x. So now we are going to be looking at cos h inverse of x. 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 So that's our next line of action. Yes, we have seen that of our sine h inverse of x. Now let's look at y is equal to cos h inverse of x. And here we are asked to solve for the y all over the x. Now solution. So here, if y is equal to cos h inverse of x, it means the value of our x will be equal to cos hy. Yes, it will be cos hy. Now, the x all over the y. The x all over the y. Remember, in trigonometry, we said when you differentiate sine x, it gives you cos x. And when you differentiate tan x, it gives you sec square x. When you differentiate cos x, it gives you minus sine x. But in hyperbolic function, when you differentiate cos hy, it gives sine hy. Okay, I'll explain that better later. Yes, under hyperbolic functions, I'll explain that. So here, the x all over the y is equal to sine hy. So it means the y all over the x will be equal to 1 all over sine hy. Yes, that's the y all over the x. Now recall, yes, that cos h squared y minus sine h squared y is equal to 1. Is equal to 1. So it therefore means that here, cos h squared y minus 1 is equal to sine h squared y. So now what we're trying to say here is that the value of sine h squared y is the same as cos h squared y minus 1. So to get the value of sine hy, removing the square, we have sine hy will be equal to the square root of cos h squared y minus 1. So it means sine hy will be equal to the square root of cos h squared y minus 1. And remember, we said let x represent cos hy. So it means here, this cos h squared y now will be x squared. Here we have minus 1. So now it means the value of the y all over the x, now, which is the same as 1 all over sine hy, will be equal to 1 all over. The value of sine hy is the square root of x squared minus 1. So it therefore means that if y is equal to cos h inverse of x, the y all over the x will be equal to 1 all over the square root of x squared minus 1. So that's cos h inverse of x. So now, number 4, this is number 5. So we're going to be looking at the last one under this hyperbolic function, which is tan h inverse of x. Tan h inverse of x. Okay, tan h inverse of x. So that's our next line of action. Yes. So now, if y is equal to tan, now let me tag this as number 6. So if y is equal to tan h inverse of x, now it means the value of our x will be equal to tan hy. Yes, that's the value of our x. Now let's see the x all over the y. When you differentiate tan hy, it gives sec h square y. Yes, it gives sec h square y. Now it means the y all over the x. The y all over the x will be equal to 1 all over sec h square y. Now recall. Yes, recall that cos h square y minus sine h square y is equal to 1. Yes, and we know that sec hy is the same as 1 all over cos hy. Yes, it's 1 all over cos hy. So now I'm going to divide through by cos h square y. Now dividing through by cos h square y, it means here we have cos h square y all over cos h square y minus sine h square y all over cos h square y is equal to 1 all over cos h square y. So in this case, cos h square y divided by cos h square y is 1. So here we have 1 minus sine h square y divided by cos h square y is tan h square y. Now the whole of this now will be equal to 1 all over cos h square y is sec h square y. So it therefore means that sec h square y is the same as 1 minus tan h square y. Yes, that's sec h square y. So if sec h square y is equal to 1 minus tan h square y, it means sec. Now let's look at this now. Let's look at this. Yes, let's look at this. From here, we said the y all over the x is 1 all over sec h square y. Now let's bring it out here. The y all over the x is equal to 1 all over sec h square y. And this is the same as saying 1 all over 1 minus tan h square y. Now, let's look at this. Here we said x is equal to tan hy. So if x, okay, recall that x is equal to tan hy. So it means our x square, or let's call it tan h square y, will be equal to x squared. Now let's take note of this. Yes. So it means the y all over the x will be equal to 1 all over 1 minus tan h square y, which is the same as x squared. 1 minus x squared. Okay? 1 minus x squared. So now this is the derivative of tan h inverse. Okay? Tan h inverse of x. So it means that if y is equal to tan h inverse of x, the y all over the x will be equal to 1 all over 1 minus x squared. Now we are going to recall the whole of this because we are going to be using them under substitution in integration. Yes. Now let's look at the whole of the functions. Yes. The summary of the whole functions. Now for trigonometry, we said if y is equal to sine inverse of x, there is sine inverse. We said the y all over the x will be equal to 1 all over the square root of 1 minus x squared. Now that's number 1. Yes, that's number 1. Number 2, we said if y is equal to the cos inverse of x, the y all over the x will be equal to minus 1 all over the square root of 1 minus x squared. Then number 3, we said if y is equal to tan inverse of x, the y all over the x will be equal to 1 all over x squared plus 1, or 1 plus x squared. Number 4, we said if y is equal to the cos h inverse, or let's sine h inverse of x, we said the y all over the x will be equal to, for sine h inverse of x, okay, for sine h inverse of x, we said is 1 all over, okay, let's look at cos h inverse first. Cos h inverse of x, the y all over the x will be 1 all over the square roots of x squared minus 1, the square root of x squared minus 1. Then here, number 5, we said if y is equal to tan h inverse of x, we said the y all over the x will be equal to, we have 1 all over 1 minus x squared. So these are all the derivatives that we have actually derived. Okay, so in our next class, we are going to be looking at how to solve functions on both trigonometric and hyperbolic functions. Thank you so much for listening.